Hello and welcome everyone to this Simpleware webinar. Thank you for taking your time out to join us today on these talks from our two presenters, which I'll introduce in just a second. Just to quickly introduce myself first, my name is Ross Cotton. I'm the Applications Engineering Manager for the Simpleware software team at Synopsys. So I manage a team of application engineers who look after the technical support and consultancy and a bit of the AI model development as well. So my role today will just be to help organize and facilitate the questions and the presentations. And next slide, please, Krim, and then we'll just also talk you through the agenda and some instructions for today's talks. So maybe notice your audio has been muted already. That's just to keep the audio nice and clean throughout the presentations. It will remain that way throughout. But if you do have any questions, please submit those into the toolbox in the GoToWebinar user interface. At the end of the two presentations, we'll reply to a selection of these questions in the Q&A. Just to make you aware, the webinar is being recorded today and will be made available for streaming shortly after the event. You'll receive an email, hopefully with that information. Any problems, please do get in touch via the Q&A. We'll try and help you out the best we can during the live event today. In the worst case, there will be a copy recording made available for streaming afterwards. And that's my part done. I'll now hand over to our two presenters. I'll briefly introduce them first. So from the Synopsys side, we have Karim Genç, one of my colleagues for the Simpleware product team. He has expertise in the patient-specific image-based workflows for the surgical planning and in silico trials and focus on strategy, partnerships, and technical marketing content. So his official title is a Senior Project Manager, and he has a PhD in Biomedical Engineering from the Case Western Reserve University. And we're delighted today to be joined by Dr. Daniel Wisnia from Yale University. Really appreciate spending his time today to talk through today's title, which is, as you can see on the screen, Collaborative Innovation with Simpleware and Yale, the Unlikely Journey to an AI Solution for Brain Tumor Tracking. So he's got many roles and responsibilities at Yale. He's an Associate Professor of Orthopedic Surgery and an Associate Professor of Mechanical Engineering and Material Science. With regards to today's talk, he's the Department of Orthopedics Director of Technology and Innovation. In this role, he leads and coordinates efforts in the use and development of technology innovation in education, research, and clinical care. Examples include robotics and navigation, the use of 3D modeling, virtual reality, and artificial intelligence. We may also hear today about Yale's master's program in personalized medicine and applied engineering, which aims to prepare engineers and medical students with the tools to develop innovative 3D solutions for personalized medicine. So thank you for today's presenters. I'll now pass on to Karim, who will talk us through the Synopsys introduction today. Thank you.
Thanks, Ross. Hi, everybody. Again, my name is Karim Genç. I'm the product manager for the Synopsys team, and I'm really excited for today's webinar presentation from Dr. Dan Wisnia over at Yale. This is we've been working together for a long time, and it's really neat to see how conversations can lead to really interesting applications that are pretty unexpected. So with that, I'll just do a brief overview of Simpleware, who we are, what we do, and I'll pass it off to Dr. Wisnia to give his presentation. So again, we're part of the Simpleware product group within Synopsys, and we develop high-end 3D image processing software. Basically, a high-level overview is you go from 3D image to a 3D model. That's our main focus. That's our main expertise. And 3D images can be CT or MRI, and then 3D models can be anything from surface STLs off for 3D printing, measurements, different types of reports and generation, models for surgical planning, models for simulation. It really depends on the user, how they define the model. We have dedicated sales support and services teams globally, and we work with customers in clinical life sciences as our primary focus, as well as other areas as well. So to give you an overview of the workflow, Simpleware for medical and life sciences, you have 3D image-based modeling workflow shown here on the left within this gray triangle here. You have your image, you bring in your images, you can do your image processing, your segmentation, then from there you generate your models, and then you can do an analysis and reporting of that. And we are considered to be best in class for medical image processing, manual to AI-enabled automated segmentation. We can generate STLs, 3MF CAD, any kind of format that you need for different contexts of use. We can customize the workflows. And typically we work within, on the right here, you can see we work within implants, guides, and surgical planning, R&D simulation and in silico trials, or point of care 3D printing. Those are kind of our three main areas that we work in. And that's traditionally, that's where Dr. Wisney and his group started in his orthopedic biomechanics lab. But then we kind of moved into an unexpected area of clinical radiology, where we can apply our AI algorithms to help automate workflows within that space as well. Again, it's bringing images to a model, and it's essentially the same workflow, just different types of applications and different tuning to make it optimized for these different applications. And we'll get into how we kind of worked our way into this area. So in terms of Simpleware software, what does it do? We have Simpleware and Simpleware Medical. So Simpleware Medical is FDA 510K cleared. We have MDR clearance over in Europe. And in terms of the software itself, you can see on this little diagram here where you can import image data. You can do your segmentation, kind of like what I mentioned earlier, doing measurements and analysis. You can integrate CAD geometries within the image space and generate your model. And then again, image to model, and then we have some scripting and automation tools that you can use, whether it be purely scripting or AI-enabled or machine learning based AI tools. So this is kind of the overview of off-the-shelf what the software does, the software that we typically license. And then when I just want to go into a couple levels of automation and how we ended up where we are today. Initially with
So we might be experiencing a few
with
technical
scripting, anything
difficulties.
you can click, you can script. So you have different APIs, macro. Oh, sorry, there, lost you there for a second. Sorry, lost you there for a second. So I'll be really quick so I can pass it off to Dan. So we have different types of scripting you can use to automate your workflows that you're doing within the software. Then the second level of automation is our off-the-shelf AI-enabled tools for automatic segmentation and landmarking. And landmarking is an important thing to emphasize as well. So it's automatically segmented, automatically landmarked for these different applications you see here on the screen. Literally head to toe, ankle, knee, hip. We have a new hip revision tool. You can do cardiac, 3D, 4D heart CTs, and we have this a really neat tool called Bone Fill. That's an AI-enabled segmentation tool that helps with the segmentation process, and I really recommend people give that a shot. So with that, also what comes within that is the university, or what I wanted to mention too is we have a Simpleware University bundle. So everything that I mentioned so far comes within this bundle. So we really wanted to eliminate the bottleneck or the kind of cost bottleneck of bringing or barrier of bringing Simpleware into research labs. So this is 50 full research licenses of the Simpleware software, not the FDA cleared version. I just want to be clear on that, of the research version. All functionalities, no technical limitations, all the AI-enabled auto segmentation tools. You can share this across the campus. Dr. Wisney and his group have taken advantage of that and will likely mention it. This is for peer-reviewed fundamental research. Any research that's being done that's for peer-reviewed papers, presentations, conferences, things like that, even if it's commercially funded, as long as it's open and free research. So we're really excited to release this as well. So this kind of gets us to our third level of automation and where we headed with Dr. Wisney and his team. So this is, we can do complete custom AI tools for people. And basically how it started was several years ago, I mentioned to Dr. Wisney, hey, as you start using Simpleware more and more, if you have colleagues who need to automate any image processing workflows, we can do it. Regardless of anatomy or imaging modality. If you can segment it, generate the workflow, we can automate that. And we've done it for orthopedic and cardiovascular OEMs and medical device companies. And we were just starting to get into some academic groups wanting to do this. So this is where typically the customer provides the ground truth, and we can quickly and efficiently train and deploy some of these tools. And this leads to this spectrum of automation that we talk about. So the level of automation we can generate or provide for the customer depends on your application. Whether And these are long-term relationships. This has been several years that we've been working with Dr. Wisney and his team, leading to these types of applications. So, on the left is very manual. So you can see on the left you have number of data sets per year and relative time savings. So Simpleware Medical, for example, 1 to 100 cases a year. So where people are bringing in image data, they're doing different types of applications. They're using these workflows, maybe for simulation, some for 3D printing, and they're fine with off-the-shelf tools. Then they can start getting into scripting, where some of these workflows can start to be automated. If they're starting to repeat some of the same processes, you can script it and automate it. And then we get into some customers who want to use our off-the-shelf AI tools for, say, if they're doing a lot of knees or a lot of shoulders, and we can really push down the time required for segmentation. And then we get into something like custom modeler. So that's where people are doing hundreds or thousands of data sets, and they really need a very accurate and repeatable and customized solution. And that's where we work with our customers hand in hand over time to develop these and deploy these. So really, this is kind of the spectrum that we offer to our customers. So any conversation we have, we like to learn what you're doing and where you fall along this, and how can we help you potentially move to the right if that's your goal. So with that, I hope that was a good overview of Simpleware. I'll pass it off to Dr. Wisnia, and he can share his screen and take it from there. So I don't know if Ross, if you can give Dan permission to share his screen.
They should have access.
There we go. Perfect.
That's good. Just, I think, Dan, you're still unmuted. Muted. If you can unmute, that'd be great. Thank you.
All right. And you can see my screen.
Yep. All good.
Excellent. All right. So thank you all for joining. I'm Dan Wisnia. I'm an orthopedic surgeon at Yale. And my focus is hip and knee replacement, but I also teach at the School of Engineering, and a lot of my research is within the 3D modeling simulation space. One of my co-investigators that I work very closely with is Dr. Tomasini. He runs our biomechanics lab, and we do a lot of 3D modeling research, orthopedic modeling research together. At Yale, we have a very strong partnership within 3D medicine. We've built a collaboration between the School of Engineering, the School of Medicine. The Department of Orthopedics has really taken the lead on this, and we hold regular research meetings, research in progress meetings to really foster a sense of collaboration on campus, and it has really fostered a lot of different projects. We have also started at Yale a new master's program that's now in its third year. And the program, it's called a Personalized Medicine and Applied Engineering Master's Program. So Dr. Tomasini and I were the co-directors of this program, and it's a one-year master's degree, and the students learn how to take high-resolution imaging, MRI, CT, ultrasound, and then translate that into 3D models, and then take those 3D models and either 3D print them, put them into a robotics, XR, computer-navigated environment, conduct research, computer simulations, finite element analysis. They also spend a full semester in the hospital shadowing clinicians, learning how at Yale we take personalized medicine from a research environment and translate it into the clinical environment. And then they also, in that year, it's a busy year, complete a master's thesis project. If you're interested in learning more about it, here's a QR code just to our website about the master's program. And if you have any questions, always feel free to email me about it. Now, as we built out our capabilities on campus, one thing that we did is we realized we needed a very strong 3D software ecosystem. So we've invested heavily in different software packages. Um, and the one of the software packages that we use quite considerably in the lab and with our students is the Simpleware 3D modeling package, but we also use Abacus, COMSOL, SolidWorks, Mimics, and MATLAB quite a bit. This is an example of a project that a student worked on in our lab using Simpleware. And I'm just going to play this video. So this is a patient who has a tumor in their shoulder. The shoulder bone, the arm bone, the humerus had a tumor. It had to be resected. This is a 3D model that we developed using Simpleware of the tumor. And then after some additional image processing, we developed this custom 3D mold. And the goal was, because this tumor also had an infection, was to remove the tumor and place this antibiotic spacer. We created this mold to pour cement into in the operating room, and then use that cement to fill the defect, and then come back once the infection had cleared to conduct a reconstruction of the humerus. So this is one application that we're doing. We have built out within the School of Medicine capabilities to do point of care 3D printing, and we have a dedicated program director who's an engineer, and she does about a half dozen cases a month of this customization and complexity. So as our 3D collaboration grew on the School of Medicine, we're regularly approached by other researchers. One individual who was coming to our weekly meetings was Dr. Bono. He is a research scientist in the Department of Psychiatry who has an interest in a rare tumor called vestibular schwannoma. And this tumor is very specific to patients who have neurofibromatosis. And the tumor, as it grows in the brain, can unfortunately lead patients to lose their hearing, lose the ability to control the muscles in their face, and sometimes lose vision. So when he approached us, we tried to come up with a plan. He wanted to be able to come up with just a 3D model of one of these tumors. And so within our collaboration, we brought together neuroradiologists, experts from the School of Engineering, our 3D innovation team, and also a research foundation with a vested interest in neurofibromatosis 2, and talked about what really needed to be done to model these tumors and understand the growth of these tumors in the brain. After these meetings, we then, using Simpleware, created some very simple mock-ups of the tumors. This is an MRI of a patient's brain who has 2 of these tumors in their brain. And this was a very quick model that we developed. And this started a conversation in terms of, was it possible to take those models and put them into an XR environment? This is a virtual reality environment in which the surgeon is able to walk through the brain and see the tumors, see what important critical structures they might be abutting to, And this is very helpful if you're a neurosurgeon for surgical planning, to be able to see the tumor in 3D space and walk through it, walk around it, and get a good sense for how to treat it, if you can even treat it surgically, or whether you should approach the tumor from another position, such as with like gamma knife radiation. So this is really helpful for surgical planning. There was then an interest in trying to automate this process. So this tumor, if you were to manually segment this tumor, it might take you 4 to 5 hours to accurately segment it. And if you are a patient and you want to know if your tumor is growing, a radiologist might look at a few slices of an MRI and give you an approximate XY dimension growth over time. But it's approximate. It's not always very accurate. It's very user dependent. And so the thinking was, let's see if we can automate the process of creating these models, where maybe it won't take 4 to 5 hours. Maybe it'll take just a few minutes. So we reached out to a tumor foundation, and we were able to recruit several hundred patients to send us their MRIs of this very rare tumor. And then with a team, research team, we created a ground truth data set, and using the Simpleware software, we created the data set and then validated it with our neuroradiologists. And then our relationship with Simpleware had grown, and we approached them about using some of their custom modeler AI techniques. And for this, we received a grant from the NIH to help fund this component of work with Simpleware. And through that grant, we were able to work directly with Simpleware and transfer our ground truth data set over to them and work with the engineers to help validate this AI solution. And the software has really worked beautifully. We are getting very high dice scores, very, very nice accuracy. And we've also then been able to write our own codes and scripts in Simpleware, where we're now analyzing the growth of these tumors over time. This is a picture of a patient who's had MRIs taken yearly, and we're able to identify where the tumor is growing each year. And these are models that were generated with the AI, and then with our scripts, we're able to overlay them and examine growth. So I'm going to stop there and open things up for questions. We've had just a terrific experience with the Simpleware engineers developing this software. It went through several iterations, and we've really found them to be just great communicators and very, very skilled. This solution was for MRI-based imaging of a brain tumor, and they were very, very accurate with the solution.
Thank you very much, Dan. Thank you very much for the talk today. Yeah, likewise, I think the team here also learned a lot during the collaboration. We learned a lot about these tumours and the impact they have on people's lives. So it was very educational and a good learning curve for us. And being able to help out in a small way with your kind of research and maybe, practice is always good. So also want to mention someone from my team who works quite heavily on this, George Heidlineker. He was one of the primary engineers on the project. So big thanks to George for that work. We do have a few questions coming in. If you've got any questions, do type those into the toolbox right now. We'll have to get through a few of those in just a second. So have got a couple coming in. First one we've got, I'll probably ask both Karim and Daniel to answer these. Do you have any recommendations for researchers who have an idea for an application they would like to automate and what their next steps would be? Maybe Daniel, do you want to maybe try and answer that one first?
Yeah, I think the first thing is, and this is just sort of the most obvious, is make sure you can get enough images. So I think that's where I would start, is by start small, collect images sort of locally at your institution, and then manually segment those and get a good sense for the size, extent of these tumors. And then I would branch out outside of your institution. And one thing that's important to know is not every MRI scanner is created equal. Not every CT scanner is created equal. So as you start to enlarge your catchment area, you're going to get images of varying quality. And once you've built out your ground truth data set, then it'll be a good time to then speak with the Simpleware folks about creating an AI solution. But I think the first thing is really just making sure you can get the imaging. That's always the biggest challenge. And then another thing to consider is, do you have a radiologist that will help you validate your segmentations for the ground truth data set? That's very critical, that you want to have the most accurate ground truth data set. And a lot of this manual segmentation that is required to build out the ground truth data set is going to be conducted by a research assistant or a student. It's critical that you have a radiologist training them, but then also validating those images.
Thank you, Daniel. Karim, anything to add?
Yeah, I mean, like Dan said, establishing that workflow, making sure you have the data. I mean, that's very important. I can't tell you how many times we've engaged with customers on the commercial, mostly on the commercial side, who want to automate their workflows and really needs support in understanding their data and how that can translate into a functional and useful AI tool, especially the segmentation. Segmentation maybe for your workflow might be slightly different than what's needed for an AI kind of ground truth type of application. But the short answer is talk to us. We're happy to have these conversations. Like I said, we work with people on the spectrum of automation, all from the very beginning to people who are customers doing hundreds or thousands of cases per month, and automating those and making those quicker and more efficient for them. But yeah, have a conversation. I think that's the best way to start. And we're happy to talk about. We love this stuff, so we can talk about this for years.
And then the other thing I want to highlight is that when you're creating the ground truth data set, sure, it's a manual process, but what's really great about Simpleware is there's a lot of thresholding algorithms and different image processing algorithms that you can use that can make those manual segmentations a lot faster. So, we have seen teams who have gone, slice by slice, sort of painting each slice of a tumor. But with Simpleware, it hasn't really been like that. We've been able to, fairly quickly come up with a few algorithms, utilizing some of the already pre-existing algorithms in Simpleware, so that we have maybe 95% of it already done, and then go in by hand and sort of clean it up. So I think that's also something to keep in mind, is that creating a ground truth data set's a hard work, and the Simpleware software if you know how to use it properly, and it is fairly self-explanatory, but the tutorials are excellent, and that's a really critical component is that you're not struggling to create your ground truth data set.
Thank you both for the answers to that question. Got a question relating to how it's kind of used in practice, Daniel. Can you provide a bit of more information about what the user has to do to run the AI model and how long does it take and so on? What's that sort of look like for the end user?
So, our solution, you take your DICOM, open it up in Simpleware, you click one button, it runs the custom auto segmentation tool. We run our software on a pretty high performance computer. Takes about 2 to 3 minutes, and then it will give you the 3D models. But just to emphasize, that's sort of how we set it up, and those were sort of the requirements we gave Simpleware and their engineers. But they have, if you need to customize it for a specific use case, there's a lot of options. But for us, I mean, it's if you give me a brain MRI that has a tumor in it, we can, I can open it up and run it and have a solution, an answer probably within 3-4 minutes.
Great, thank you, Dan. Got a question regarding open source tools. So, with all the open source tools out there, like Slicer 3D or 3D Slicer, and then obviously on the AI training models, there's some solutions out there. What were the advantages of working with Simpleware specifically to build this AI tool for your application?
I think one of them was we got to work with just very highly skilled engineering team that has an incredible amount of experience doing this. So for us, we didn't have that learning curve of having to learn how to use those other packages and how to use those other AI tools. And so I think that was like one of the major benefits was that experience. And then, the engineers are also very familiar with different types of DICOM formats. We, to really make our solution broadly useful, we included MRI imaging from all over the world. So all these different protocols, different MRI machines, and they were able to, troubleshoot any of those challenges that come with that.
Thank you. Karim, anything to add from your perspective on open source versus commercial? I think.
Yeah, sorry, I kind of lost my connection there for a bit, but yeah, I guess what was the question? I'm sorry.
So we're looking at whether kind of going down the open source route for these for sort of training and building models, or going through our route, I guess.
Yeah, I mean, I definitely there's some nice open source tools that are available. I know MonAI has a good relationship with Slicer, and there's ways you can use those tools. So yeah, if your group has that expertise and wants to build your own, definitely there's ways to do that. I think the advantage of working with us is just that it's on. Everything is based off of the Simpleware software, which is, again, like I mentioned, FDA cleared, MDR, all that clearance is there. And we have a lot of experience building these tools. And once we get this data, typically we say around 3 months is about the time for us to deploy something for your application. That all can, obviously the timing of that can fluctuate depending on your application, but there's a lot of expertise in Ross's team, a lot of tricks and little things that they've learned over the years to deploy things quickly. And also, again, if you're building something, say in MonAI, you get a segmentation tool, but the likelihood that it's going to work 100% with a single click is likely not going to happen, and you'll need some cases where you're going to have to clean it up, and making sure you have something that's quick and efficient, is like the Simpleware software is something we can provide. So yeah, so there's definitely, I definitely don't want to downplay the advantages of open source tools, but as everybody knows, the advantages and disadvantages are pretty typical when comparing open source to commercial in terms of, usability, technical support, things of that nature. But I have colleagues who were excited and announced to the world when they were Windows free and completely on Linux. So there's folks like that, and definitely respect that. But for sure, there's things to talk about for that.
Great. I think we've got maybe time for one last question that's come in. Is this AI feature readily available on Simpleware, or is it only included in the university bundle? Grim, do you want to take that one?
Yeah, so to be clear, the tool that Dan was talking about is not in the software. This is a tool that was developed specifically for his team based off of their data and their IP. So whenever we're doing a custom solution, that data is sequestered to them. There's a firewall between us and our software and their AI solution. So for example, any of our off-the-shelf AI tools, none of that was done, say we did a hip auto segmentation tool. We've had customers where we've done custom solutions for the hip. None of our off-the-shelf tools are based off of that. That's completely theirs, and it's deployed for them and their use only, and they can decide how to use it. If you want to contact Dan and his group and say, hey, can you look at our data? You can talk to them. That's up to them, and how they want to handle that. So for us, how our customers use the tool, there's some contractual limitations, but it's pretty much up to them. In terms of the university bundle, it comes with all of the off-the-shelf AI tools that I mentioned. So in terms of what they are, it's for C. If we have one MRI AI solution, that's for the knee that we have. The rest for CT is ankle, knee, hip revision. If you have like metal artifact, things like that, spine, shoulder, and CMF. And then we have heart auto segmentation tools and a valve analysis tool that's an AI solution as well. So those are all in the university bundle. That's where they come from, or that's where they're located. But if you want a custom solution, you can talk to us and we can see it. We can have that conversation.
Thanks for clarifying, Karim. And maybe just to add that, so we've got off-the-shelf AI. The custom AI is not just segmentation. We can build things around it. Daniel's team have got experience. They can build in the post-processing, the measurements, and the automation of that with the Python API. But that's something we can also help with as well, whether we do it or advise you as well. So it's not just a segmented mask. You can look at things like landmarks to determine sort of left, right sizes, measurements, feed that into fitting planes, for example, or other kind of measurements, and then towards customizing the exports as well. So if you've got a specific export that needs to be a certain characteristic or number of triangles or something like that, or a color, that's all automatable. So the custom one can really go quite far from DICOM import to model export, including the AI side of it as well. I think we have covered all the questions that have come in. Daniel, would you like to have any last final words from your side today?
Just if you have questions, feel free to reach out to me. We've found that Simpleware just as a software package has been excellent for our research and for our students and for our master's program and what we use at our 3D printing center here. And we've had a very good collaboration with Simpleware in their assistance in putting together this custom solution. And overall, it's been incredibly positive. And if you have questions, feel free to reach out.
Thank you. And Karim, from your side?
Yeah, just to say that we build the tools, but we need the expertise and the experts who have the questions and the clinical relevance and the data. And I think with this work with Dan and Yale and his group has been just that, which has been excellent and nice to see, where we can provide our expertise that can build the tools that they need to do their clinical workflows and hopefully improve the lives of patients. That's what we're all here for. So I'm hopeful for that, and really want to thank Dan and his team. That it's been excellent working with you guys, and really enlightening from my kind of personally and professionally. It's been excellent. So thank you.
Thanks, Grim. Yeah, just to reiterate exactly what you just said, I was going to say the same thing. So, yeah, we've learned a lot along the way. It's been great. We've learned a lot by doing these. We can help out in our little way, and yeah, we look forward to seeing more from your group and more publications, I guess, as well. So we'll look out for those. Okay, thank you everyone for your time today joining us. If you get any other questions, follow up afterwards with us via email. But yeah, thank you for taking your time out, and we look forward to hearing from you again soon. Thank you very much, everyone. Thank you.
Thank you.
Take care.
Bye.